Okay, so we're going to look at polynomial functions and their end behavior. The point of this is it's another kind of thing that you should know without a calculator. So should know without calculator. Otherwise, a lot of this would be kind of silly because, you could just put it in your calculator and look at the end behavior. So that's what takes this different from being something I could ask a freshman in Algebra 1 versus, a pre-calculus topic. So we know we have linear functions. We know this, slope is 0. This is a line that has an undefined slope. And then this is a positive slope. This is a negative slope. We're going to make a column here, number of x-intercepts, or that's real zeros. So with a line, we know we either have no x-intercepts or 1. So if it's a degree 1, we can have up to 1 x-intercept. It could have no x-intercepts, right? Because a horizontal line could be entirely above or entirely below the x-axis. It could never cross it. With parabolas, that's our x squareds, our degree 2s. This is a greater than 0. This is a less than 0, right? So if a is positive, essentially, my ends are up. If a is negative, my ends of the graph are pointing down. And a parabola can have 0, 1, 2, or 3 x-intercepts. So just to kind of show that, obviously we can have a parabola, right, that goes through twice. We could have a parabola that's just tangent to the x-axis, so it just hits it at one spot, 1 point. Or we could have one that's entirely above the x-axis, or, it could be entirely below the x-axis and does not have any x-intercepts. Now, with a degree 3, so degree 3, because that's an x cubed, we can start down and up. That's if a is greater than 0. This is also a greater than 0. We start down and up. So I always say if a is positive, it's one of these: start down and up, start down and up. Could just gradually increase like this first one, or it could increase to a maximum, decrease to a minimum, and then increase. Now, it could be one that's gradually decreasing. Here, a is negative, or it could decrease to a minimum, increase to a maximum, decrease after that. This is still a is less than 0 because it's ending down. So in the a is less than 0, so when a is negative, it's ending down. When a is positive, it's ending up. And this could have 1, 2, or 3 x-intercepts. So if you think about it, it can't have 0 because this is definitely going to cross, the x-axis. So if you think about it, if it's going up and down infinitely, somewhere it's going to cross the x-axis, even if it's a little more wiggly in the middle, even if it's falling, that type of thing. Now, degree 4, so again, exponent 4, is going to be very similar to our degree 2. So we notice we can have something that looks like a parabola opening up, parabola opening down. So here a is greater than 0, here a is less than 0. A, right, I hope everyone understands, is the coefficient of the, it's the leading coefficient. Now, if it's a degree 4, it can get more wiggly in the middle because it could hit the x-axis up to 4 times. Again here, though, the ends are up, so that means A has to be positive. When the ends are down, here the ends point down, A is negative. This could have 0, 1, 2, 3, or 4 real zeros. Finally, degree 5, if it starts down, ends up. So when it ends up, A is positive. When it ends down, A is negative. Ends up, A is positive. Ends down, A is negative. This just gets a little more wiggly. Ends up, A is positive. Ends down, A is negative. So the only difference between a degree 5 polynomial and a degree 3 polynomial is the degree 5 can hit the x-axis up to 5 times. So that's why I can get a little more wiggly in the middle. 1, 2, 3, 4, or 5 real zeros or x-intercepts. So what's going to happen is any even degree polynomial, a degree 2, a degree 4, a degree 6, those are going to be, if A is positive, the ends are up. A is negative, the ends are down. In fact, let me do a little summary here. So if we have an even degree polynomial, if A is greater than 0, or maybe I should just say, if A is positive, then the ends are going to be up. Could be more wiggly, but the ends are up. If A is negative, the ends are down. And again, if it's a degree 4, degree 6, could be even more wiggly, but the ends are going to be down. If it's an odd degree polynomial, so a degree 3, a degree 5, a degree 7, a degree 9, if A is positive, then it starts down, ends up. Could be more wiggly, but it's going to end up. So when you're going left to right, when I say end up, I mean when you're going from left to right, it ends up. If A is negative, it's going to end down. So on the right-hand side, it's going to be down. Okay, so I say a polynomial is a function. They give that big long equation. Basically, the A's are constants called the coefficient of the polynomial. N has to be greater than or equal, or N greater than or equal to 0 is an integer. X is a variable. So they're basically telling you the exponents have to be integers. They can't be fractions. X is a variable. A sub n is not 0, because if we think about it, if A sub n was 0, that would wipe that out. If it is not equal to 0, if A sub n is not equal to 0, it is called the leading coefficient. N is the degree of the polynomial. So the exponent we know is the degree of the polynomial. The domain of the polynomial is all real functions. Every polynomial function. So way back when we did, Unit 3, and we did all those domains, we kept saying if it's a polynomial, its domain is all reals. The only time we had to look, for anything different for a domain was if we had a fraction, then the denominator couldn't be 0. And if we had a square root, we didn't want a negative under the square root. But polynomials were always all reals. So it says, tell whether each of the following is a polynomial function. If it is, state the degree, tell the end behavior using limits. Limit means what value is y approaching as x approaches a certain value, which we talked about a lot in the last unit. So here's the thing. If I were looking at this, now, first of all, I want this written in standard form, just so that I can determine that this is a degree 6, right? Highest exponent is a 6. That's that right there. And the leading coefficient, which from now on I'll just abbreviate LC, is negative. It's actually -4. I don't care about the 4. What I care about is that it's negative. So those two things, it's an even degree, negative leading coefficient. That means I know the ends are down. It could be more wiggly, could even be more wiggly than that, could hit the x-axis up to 6 times, but I don't care about that. All I care is I'm talking about end behavior, so I want to know that the ends are down. So when I do the limit of f of x as x approaches negative infinity, well, if the ends are down, then the y is approaching negative infinity. If I want the limit of f of x as x approaches positive infinity, then since the ends are down, that's going to be negative infinity. So what it's saying is if I move to the left on the graph, my y's are going to negative infinity. And if I move to the right on the graph, my y's are going to negative infinity. All right, so the next one's already in standard form. So I can say this is a degree 2, because that's the highest exponent. Leading coefficient is negative. So this is a parabola that opens down. So again, if I'm doing the limit of f of x as x approaches negative infinity, that's going to be negative infinity because the ends are down. Limit of f of x as x approaches positive infinity is negative infinity, again, because the ends are going down. Now the next one, the problem is it's not written like a polynomial like the previous two. Well, so some people might think, oh, I'm going to have to FOIL that all through. Well, no, you don't, because we only care about what the leading term is doing, because that tells me the degree of the polynomial. It also tells me where the leading coefficient is positive. So what I want to think is if I multiplied this, so if I multiply leading term is x to the 4th. So, right, this would be, this to the second would be an x squared times another x times another x. So that would be an x to the 4th. So the degree is 4. The leading coefficient here is positive. So what does that mean? That means the ends are up. Could be more wiggly in the middle, but still the ends are up. So all I care about is when I do the limit of f of x as x approaches negative infinity, my answer would be infinity because my ends are up. If I do the limit of f of x as x approaches infinity, it would again be infinity. So it's saying to the left on the graph as x is going to negative infinity, my y's are going to infinity. To the right on the graph as x goes to positive infinity, my y's are going to infinity. Okay. Next one is a degree 3. Leading coefficient is positive. Okay, so the last 3 examples we looked at were all even degree polynomial functions. They were degree 2, degree 4, degree 6. So either the ends were both up if it was a positive leading coefficient, down if it was a negative. Well, now we're getting into an odd degree. We've got a degree 3 positive leading coefficient. That means it starts down, ends up. It could gradually go up or it could reach max and mins, but it starts down, ends up. So when I do the limit of f of x as x approaches negative infinity, as you're moving to the left of the graph, where are your y's going? They're shooting down to negative infinity. Limit of f of x as x approaches positive infinity. As you move to the right on the graph, where are your y's going? Well, they're shooting up to infinity. Next one is not multiplied through. So again, you don't have to multiply it all through, but what you want to think of, so if I FOILed this out, this would be an x squared times the leading term here is a negative x. So that'd be a negative x cubed. All I care about is what is the leading term for, term with the highest degree. So I would think, okay, this is a degree 3 polynomial. Leading coefficient is negative, which means starts up, ends down. Negative ends down. Could be more wiggly, but it's going to end down. So remember, you always trace from left to right. So this is ending down. Limit of f of x as x approaches negative infinity. Well, as I move to the left on those curves, my y's are shooting up to infinity. As I move to the right, so as x approaches infinity, my y is shooting down to negative infinity. So what you might notice, even degree, both your answers are going to be infinity, or both of your answers are going to be negative infinity. With an odd degree, your answers are going to be one of each. Okay, this is a degree 7. Still, degree 7 is an odd degree. Leading coefficient is negative. So limit of f of x as x approaches negative infinity. Limit of f of x as x approaches positive infinity. All right, so if it's odd degree, negative leading coefficient, again, it starts up, ends down. Sure, it could be more wiggly in here. Probably not that much, but, could be more wiggly, but basically it ends down. So as x goes, so it starts up, ends down, negative ends down. As we go to negative infinity, we're up at infinity, right? As we go to positive infinity, it's shooting down to negative infinity. So similar to the last one, because it was an odd degree with a negative leading coefficient. Okay, write a polynomial function whose real zeros and degree are given. So they're telling us it's a degree 3, and those are the zeros. Well, if you think of how you would solve a polynomial function, normally you would have, something set equal to 0, and you would take the factors, like to get x is negative 1. So think about it. Right now we have x, actually, let me put this over here. We got x is negative 1, we got x is 1, and we got x is 3. So if I were solving a function who had those zeros, the factors would be this, right? If I set that equal to 0, those would be the factors I would need to get those zeros, which means that the polynomial function would be if I multiplied all of this together. So this would be x squared minus 1, outers and inners would cancel out, times x minus 3. So if I FOIL it through, there's my polynomial function that has zeros at negative 1, 1, and 3. So here, x equal negative 4, x equals 0, x equal 2. I know it's a degree 3 polynomial. So my factors, this x plus 4, x minus 2. So think about it. If you set each of those factors equal to 0, would you get what's up above? Yes, right? So that's where we're getting that from. Then we're just going to multiply through. So I'm multiplying these two, then times the x minus 2. So I'm getting x to the third minus 2x squared. So this is just our, double distribute, right? We're distributing the x squared, we're distributing the 4x. All right, last one of this type. So now they tell me -2 has a multiplicity of 2. So -2, they're saying, occurs twice. So that means x plus 2 occurs twice, giving me x equal -2, x equal -2 if I set it equal to 0. 4 is a multiplicity of 1, so that only x minus 4 occurs once. So this is x squared plus 4x plus 4 if I FOIL, times the x minus 4. So that's x to the third minus 4x squared plus 4x squared minus 16x plus 4x minus 16. That's me distributing through. So it's x to the third minus 12x minus 16. Okay, so x minus c to the mth power. C is a 0 of multiplicity m. M is the number of times the 0 occurs. If a 0 has an even multiplicity, the graph kisses the axis at that 0. If it has an odd multiplicity, then the graph is crossing the axis at that 0. Kisses the axis, another way to say kisses the axis is tangent to. What does tangent to mean? Well, it just means it touches it, and then turns around. So it just touches in one spot. That's tangent. Okay. So for the next one, sketch a possible graph of the following function. Okay, so here's what we're going to do. We'll make a chart, zeros, multiplicity. Oops. All right, I got something in the way there. Zeros, multiplicity, and then whether it kisses or crosses. Okay, the zeros. Well, let's think about it. If you took this function, set it equal to 0, you would, to solve this, you would divide out the 4, and then set both factors equal to 0. So you'd set x plus 1 equal to 0, you'd get -1, you'd set x plus 3 cubed equal to 0. To solve that, you would take the cubic root and get x plus 3 equals 0. X is -3. So basically, your zeros are -1 and -3. Now, 0 has a multiplicity of 1. Why? Well, because the exponent of x plus 1 is 1. This has an exponent here of 1. This has an exponent of 3. So -3 has a multiplicity of 3. The multiplicity is the exponent. It's the number of times that 0 occurs. Well, we said if we have an odd multiplicity, then the graph crosses the axis at that 0. So I know it crosses. Now, the only other thing I need to make a graph, we always want to know x-intercepts, y-intercepts, that type of thing. So I need a y-intercept. Y-intercept, we did this in the last unit, make x be 0. So it's like I'm doing f of 0. So it's 4 times 0 plus 1 times 0 plus 3 cubed. 4 times 1, 3 cubed is 27. So my x-intercept is 108. Now, for this first part of the unit, we're just doing very rough sketches of the graph. So I'm going to put this up here since I'm running out of room a little bit. So what I know is at -1 and at -3, I have zeros. Zeros are x-intercepts. All the way up here at 108, I have a y-intercept. Now, the other thing I know is that this would be, let's think if I multiplied this whole thing through again. My leading term would be 4x to the 4th, right? If I multiplied through, because it's an x cubed times another x times a 4. So it'd be 4x to the 4th. So the degree is 4. Leading coefficient is positive. So that means my ends should be up. It should cross at -1 and -3. And it needs to go through my y-intercept. So that would be a sketch of the graph. So without me touching the calculator. Now, yeah, I don't know where that minimum is, but we're just doing a sketch of the graph. For this one, last one, so let's see. I could do, the same thing I was doing before, zeros. Sometimes I abbreviate multiplicity, kisses, or crosses. So let's think of setting these equal to 0. If I had 3x minus 1 squared and I set it equal to 0, I'd square root. 3x minus 1 is 0. X is 1/3. So 1/3 is one of my zeros. It has a degree of 2, or a multiplicity of 2. If I set the other one equal to 0, x minus 1 cubed equal to 0, cubic root, x minus 1 equals 0, x equals 1. That has a multiplicity of 3. So kisses, crosses. Even multiplicity, it kisses the axis. Odd multiplicity, it crosses the axis. Y-intercept, we're going to do f of 0. So this is 3 times 0 minus 1 squared, 0 minus 1, 0 minus 1 cubed. So let's see, that's -1 squared, which is 1. This is -1 cubed, which is -1. So my y-intercept is at -1. Okay. So I've got to take everything I know. I know that there's a 0 at 1/3, so maybe right about there. There's a 0 at 1. There's a y-intercept at -1. And then the last thing I have to look at is the degree. So let me put this over here. Degree is 3, 4, 5. If I multiply that through, it'd be a 3x to the 5th. So the degree is 5. The leading coefficient, so if I multiply this whole thing through, it's going to be 3x to the 5th. Leading coefficient is positive. So that's for this, which means it starts down. It has to kiss the axis at a third, cross at 1, and it ends up. So it starts down, ends up. All right, that's it for day 1.